A wizard is never late. Still working on the beard.
You're late.
Yeah, apparently. Okay, welcome to the session. So I'm Jonathan, that guy, and this is the last of my talks this conference, and therefore the last of my holiday photos that you have to put up with. So yeah, this was kind of nice.
Where is it?
That is Switzerland as well. They've all been Switzerland. I went to Switzerland to get some nice, cool mountain air, and it was hot. In like 2,000 meters up. What's going on? Okay, so anyway, welcome. And what I want to talk about today is this little project, MoarVM, which is, I guess, maybe actually not so little. This is probably maybe quite new to everyone here. It's the first time I've talked about it. It's probably the first talk that's being given about it in Europe ever, unless somebody has done a secret one I don't know about. So, what's a VM first? Let's just I like to define the things we're talking about. What's a virtual machine about? Because VM shows up in the name. So what are we talking about here? Well, a VM is something that we use to provide a runtime environment for a language or some language implementations. It tends to have several responsibilities. So we expect it to execute instructions, perhaps by interpreting, possibly by JIT compilation. Normally, any good interpreter these days is doing a combination of the two, because you don't want to spend time doing the JIT compilation stuff unless you actually have some benefit out of it. It tends to provide memory management. So all that nice thing where we can just create objects and they disappear at the right time or the wrong time. But depending on, there's all kinds of issues there. But basically we have something that supports allocating and deallocating memory automatically for us. And that might be through some kind of reachability analysis where we try and start from objects we know are good and follow the paths to find all the other alive ones. Or it might be reference counting or something like that. They also then tend to offer a built-in range of data structures and things to manipulate those. So, for example, arrays may exist, and then there'll be a set of operations which are valid to do on array-like things. And then beyond that, they typically tend to abstract away details of underlying operating systems. So things like, the difference between threading on Windows and pthreads, or abstracting away different ways of doing input and output. So these are the sort of typical things that we sort of expect a VM to provide. And there's a whole bunch of them out there. So the original plan, we go all the way back to the early days of L6. This is way before I was involved. Plan A was that the Parrot virtual machine would be built in parallel with doing the Perl 6 language design. And in theory, if you do stuff in parallel, then it goes faster, right? The only thing is that you have to remember that you need some synchronization primitives in there now and then. Things didn't necessarily go quite as planned. And by the time I was involved with Perl 6, there'd already been a Perl 6 implementation that's being built on Haskell with hooks. And if you look at the reality today, Rakudo Perl 6 already runs nicely on the JVM. And you came to my session yesterday, so we'll be doing some nice stuff taking advantage of the JVM threading model. And also there's been the Perl 6 implementation called Nietzsche, which also got a very long way. And that runs on the .NET Common Language Runtime. So Perl 6 has kind of evolved into being something that is not tied to a specific implementation, not tied to a particular virtual machine to execute it on. So we're sort of here today, and I could kind of, one of the things about working on the project is you can kind of get a picture of where things will be in a year or in a couple of years. And you sort of are always forward thinking a little bit. And one of the concerns that I could see coming about where things were going was that we could do the JVM port, and I was pretty confident of pulling that off. I didn't quite, we actually beat my expectations in terms of delivering what we have so far. I thought it would take a bit longer to get where we are. But that's good. We got there. But what I could see the problem being is that we would get to the point of having Rakudo on JVM, and I could see that the Parrot project was kind of struggling in various ways. And it's kind of telling, performance-wise, that on the JVM, once you discount startup time, Rakudo typically runs faster than on Parrot. That's mostly worrying because I spent almost no time at all really doing serious optimization work on the JVM, but I spent some years trying to get this run fast on Parrot. So that's kind of a big red flag there. But I can kind of see that we're going to start running into this situation where maybe people start to get a little bit worried because trying to see a way to get Parrot in the shape that we maybe wanted it for Perl 6 was looking kind of difficult. I prefer to be able to get something I have from where it is to where I want it to be, rather than saying, let's start over. The threshold for me to say it's easier to start over is relatively high. And all the way through doing Rakudo, we've refactored significant components without throwing away the rest of the stuff. Even in the last big rewrite that we did of lots of Rakudo, we didn't rewrite the grammar. We didn't really go and change all the action methods and stuff. We kept the same AST, that all changed over later. So we've actually done a series of small evolutions there. But what I could see is people are going to be concerned that, okay, so that on the JVM or on the CLR, we have some answers that look kind of promising. And then, what if I don't want to run on one of those? And just after my JVM talk on Monday, somebody came to me and says, how do you feel about building, Perl 6 on JVM when it's maintained by the evil Oracle Corporation? And I said, well, I don't really think about it that much. I mean, I work as a C# programmer, so I'm tied to the evil Microsoft Corporation, right? I mean, So anyway, I could sort of see from this that maybe we could do with something that sort of filled that niche. And the sort of, I was sort of contacted by the other person, particularly Matthew Wilson, who was a dichotter, and we talked a bit. And one of the things I kind of realized in all of this is that you kind of talk a lot about the ignorance curve. And basically the idea is as the project goes on, ignorance on average decreases. But in many projects, and this isn't just my involvement in Perl 6, I've seen this, but in a lot of projects out in the real world, what happens is you sort of get this aha moment on the project when your ignorance of the domain you're working in suddenly decreases. In the Rakudo development, that was actually when we did what we call the non-branch, which is where we put in the new object model stuff. So now we'd sort of learned a load of the lessons, and just to tell you about this, what we kind of realized was that at times it sort of felt like we're trying to build the Perl 6 we now knew we wanted on top of primitives which were kind of designed assuming that Perl 6 would be, in some deep ways, a bit more like Perl 5. So it sort of felt a little bit like cutting the hedge this way. It looks like fun, but it kind of isn't. Just to give a concrete example, one early one was namespaces. And I sort of, before I was involved, I vaguely followed what was going on. And I do remember there was a big discussion on the Parrot mailing list, for example, about how should we do namespaces? Should we have a big hash of names that's completely flat, or should we do something hierarchical and it's more like a hash of hash? And I think the answer ended up being the one on the right. But in the end, it turns out that actually packages in Perl 6 are really kind of weird. You can have lexical packages, you can have anonymous packages, and within each of those, they can also have other packages, but it's not really a distinct sort of thing from the type system. What you actually have is what we call a type object, which might represent a class, or it might just be a simple module, or it might just be a role. And hanging off that, you have something called a stash, which is where we actually install the symbols in the package. So that was the factoring that we actually ended up needing, which basically meant that that's where things got going. Now, I think in the beginning, and maybe Larry can correct me, but I think in the beginning we didn't maybe have the notion of lexical packages. Did we? Can't remember. Oh well. But either way, So that's just one of many, many examples. So the question really was, well, what if we take the things we know now, because now we actually have a very good idea of what you need to implement Perl 6, the primitives that it depends on. And one of the nice things about doing the JVM project is it's made it very, very clear to us what we need, because we've had to build the abstractions in various places to let us target multiple VMs. So we actually now have essentially a very concrete way of describing you need these operations which do these things, and you need to be able to compile these AST nodes with these semantics. And if you can do that, then you should be able to run things. So essentially the question was, what if we take exactly that set of things, nothing else, and just build a VM that does precisely those? What would it cost, in terms of time and resources? How difficult would it be to do that? So I kind of pondered this, and after a while, I said, well, okay, maybe we can draft something to sort of get a sort of picture of how hard it might be. So some of the first things I did was, well, what don't I want? What are the things that I really do not want to do in this project, and want to have as sort of almost burn goals? If any of these things come up, then this is a sign that I need to worry. One of them was run all the languages. That's an explicitly different thing that Parrot has as a goal that we don't have in MoarVM. Okay? MoarVM, basically, if we don't need it for Perl 6, it doesn't get added. Okay? Maybe someday in the distant future, which I'm not thinking about now, that changes. But for now, if we don't need it to meet a Perl 6 goal, it doesn't go in. It doesn't even need discussion. Have a textual assembly or intermediate language. That's an ungoal. Okay? The JVM doesn't have it. Now, the thing that makes this a big distraction is that you end up going and doing language design. Language design is not really that easy, especially if you're trying to do VM design as well. And that's another of the things that I kind of learned from Parrot, that they ended up with this textual assembly language. People were not very fond of it. Yeah, that's a nice way of putting it. But also, it became a bottleneck, because what we ended up doing is having a compiler infrastructure which basically generated this textual language. So generating text is annoying and slow. So we generated this text, which then got passed to be assembled into bytecode. And it's like, that's sort of a text generation in the passing phase more than we need. So there's no real need to want one. We do have a dumping language, of course. You can take the bytecode and feed it to the VM and tell it just dump this out in a human readable form. And it'll give you something fairly nice. There's no way to actually take that and get it back into bytecode again. So we don't actually need it. So don't waste time on it. So we didn't have any official assembly. We simply don't need that. The compiler emits a tree. The tree gets turned straight into bytecode. Publicly discuss design calls for weeks and weeks and weeks. This had to be done on a fairly, time budgety thing. The initial year of MoarVM development was done in secret. Very, very few people knew this was happening. In fact, by the time MoarVM was actually made a public project, it was already at the point where we had a cross-compiler that could take simple NQP programs and run them on the VM. And when I say simple, I mean, yes, they had things like classes, and we didn't have grammars yet. We did have quite a bunch of interesting features in there. Another one goes, add threads later. Okay. This one's a bad idea. So get threads and make the GC aware of them early. Okay? So one of the other things, if you don't actually have a way to write any kind of test involving threads fairly early on, then of course what happens is you don't end up going and putting in the various mutexes or locks or lock-free things and synchronization things to actually keep the interpreter itself sane as you go. So you end up with all of them missing at some point off in the future, and then it's a horrible project to try and retrofit it. And yeah, it's just generally a very painful thing to do, and there's not a high success rate of doing this. In fact, maybe even close to 0. So, what was the overall design of this? Well, it's kind of saying, well, what do we already have designed that we can reuse, and then what do we need? One thing that, thankfully, was not a concern was the object system. Because some years ago, as part of the Rakudo project, we came up with something called Model, which essentially is a set of primitives for building an object system. I'll talk about it in just a moment. But essentially, that was always designed from day one to be something not only that we could implement on Parrot, on the CLR, on the JVM, but if someday we wanted to bootstrap it from 0, it would be possible to do that. And that was something that was considered many, many years ago before this project was even considered. Next up, we really needed to think about GC, and Perl 6 makes a lot of garbage. There's no two ways about it. It just, all the scalar containers, all the immutable bits, because we encourage people to program functionally as well. That's fine, but it tends to make quite a lot of garbage. And at the same time, it represents all kinds of things as objects. So a class, well, it has a meta object, which describes how it works. Well, that's an object. So generally, the objects either last quite a long time or they're fairly short-lived. And if you're going to cope with that in a good way, you really need to have some kind of generational garbage collection, something that deals with new objects and old ones in a different way, so it doesn't have to consider the whole heap. And ideally, we'd be able to also parallelize it. Now, there's a subtle difference between parallel and concurrent garbage collection. One of them's tractable, and one of them will give you a headache for years. Parallel garbage collection is just about taking what you would do in a serial garbage collection, and stop the world, and then do all the work, but saying do that work over multiple threads. Okay, so it's stop the world, do the work, probably on multiple threads, and keep going. The alternative is concurrent collection, where you're trying to do the garbage collection mostly while the program is still running. I went away and spent a while reading the literature on this. I came away knowing I did not want to do this anytime soon. Maybe, some years, but no, it is extremely difficult to do. And the timescale for the project would probably be at least doubled simply by doing this, because of the complexity. Another thing that we still had to design, but only had to worry about so much, was kind of the instruction set, because we knew exactly what set of ops were needed for Perl 6 by now. We'd already got the NQP offset. Now, it's not a perfect offset for the VM necessarily. There's things that you're missing. There's things that you don't want to do like that as VM level ops. But it's a very good starting point. And by following that, it means we can align things very well. So and you knew that that was the goal. The goal was to build something that could turn those into something with VM. Of course, we knew we needed Unicode support, and this was the time to actually, since we were going to have to do strings from scratch, to actually nail the NFG thing, which I have a slide on in a moment. And then, when you build something, I always sort of think, well, the things that are critical to what you're doing, the things that are really at the heart of your project, that's the bits you want to design yourself, write yourself, and so forth. But when you have things that are off on the side, now they're not really the core concern, and when there's a perfectly good library that's already solved them, or at least a reasonable library that's already solved them, there's no reason to go and reinvent that wheel. So there's a bunch of places that I wanted to just say, well, let's just go and take existing things, we've already solved these problems, and just use them.